Alright, it's an intro video to our 7th pattern. We have gone through quite a few: 2-pointer, fast and slow, sliding window, merge intervals, in-place reversal of a linked list, 2 heaps. Now we're at the K-way merge, number 7. 20% through the course. And yeah, let's check it out. So here you're trying to merge K as an arbitrary number of sorted data structures, such as arrays and linked lists, into a single data structure that maintains the sorted order. So it's an extension of the standard merge sort algorithm. I remember doing this in uni, which merges two sorted data structures into one. So for the rest of the explanation, arrays and linked lists are just lists. Okay, so these are the different methods to do that. You can use a minimum heap, like this diagram. I think it's just best to show it rather than read too much. So you store the first index of each array in the minimum heap, and the goal is to merge all these arrays into a new array and keep them sorted, in this case in ascending order. So the earliest thing will be on top of the heap. We pop that. Whenever you pop something from an array, you add the thing following it to that heap. From that heap. So you store the first thing in the array as well as what array it came from. And when you pop something from it, you add the following elements to that array. So in this case, 4 is going to be to that heap. So in this case, 4 is going to be added to the heap, like you can see here. And you just keep doing that, popping, adding, and you will get yourself a sorted array. It's pretty cool. Super efficient. It's done. 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 This is sorted. The sort when you merge all these and keep them sorted. So that's one method. And they both yield the same result, right? They both yield the same result. And this one is very similar to merge sort. Groups of 2 and repeatedly merge them. So for example, so you take these two arrays. You merge them first repeatedly, right? So these two arrays, you merge this one, compare it position by position, one by one. Like it's like a 2-pointer problem at this point, but 2-pointer, 1-pointer per array. And you evaluate which is bigger, you add it, then you keep it here. You just keep comparing them, like so. And moving the pointer when you've added, you move the pointer on a certain array when you added it to this output array, so you get to the end. You do the same thing for this one, then you do it again. Sounds like recursion to me, and you're done. So this is one type of problem that can be solved. So the median of k sorted arrays. So if the arrays are already sorted and you want the median across all of them, since they're already sorted, if they weren't sorted, you would probably need to sort them actually individually. But if it was a single array that wasn't sorted, you would use a two heap pattern. So you just do the merge that we just did, that we saw earlier, and the median is, if it's odd length, if the array length is odd, just get the middle. If it's even, add the 2 middle elements and divide them by 2. That's it. So yes, use this pattern if it involves sorted arrays, a matrix of sorted rows or sorted columns that need to be merged, either for the final solution or for an intermediate step. If you want the kth smallest or largest element in a set of sorted arrays or linked lists. These conditions. So if it's not an array or linked list, don't use this solution. If it's not sorted, or it's sorted but not according to the way we need it to be to solve the problem, then don't use it. Real world problems. So merging tweets in a feed. If you want to add new tweets to an already populated feed in chronological order, and if this, I didn't understand this, so I'm not going to bother talking about it. So what problems use a K-way merge and what use some other pattern? So find out if a string is a palindrome. I know it's some other pattern. 5 sorted arrays, we just saw that. Middle of a linked list, actually that's a fast and slow pointer problem. The second largest number in 20 sorted arrays. This has to be this guy. Let's see. Boom, done. We understand. So yeah, we'll be going through quite a few problems to cement this in our minds, starting with the merge sort array one. See you next time.